Hello everyone, my name is Mohammed Suhaib. This is my internship project titled Washing Machine Simulation using Picsimlab under Emertxe. In this presentation, I will explain what I have learned, how I have implemented, and how I have approached this project. What is an embedded system? An embedded system is a dedicated computer system designed to perform specific tasks. It usually uses a microcontroller or microprocessor. Examples like washing machines, microwave ovens, and medical devices. Project is a perfect example of embedded system application because it simulates a washing machine controller. The overview of this project and the goal of this project was to simulate the functions of the washing machine using the Picsimlab simulator. It uses a PIC16F877A microcontroller to control the washing program's water levels and washing functions. This helped me to learn embedded programming while working with a realistic simulated environment. My key objectives were to replicate real-world washing machine operations in a simulation, to learn microcontroller-based programming in embedded C, and to understand how to manage user inputs and outputs for an appliance. The system architecture. In this slide, we can see the architecture of the system. The PIC16F877A is the core controller. Inputs includes various switches for user selection and status monitoring, and outputs include the motor, buzzer, and the LCD display. The system simulates these functions virtually in Picsimlab. The functional flow overview. Here we can see the functional flow overview of the washing machine. The user powers on the machine, then selects the washing program, chooses the water level, and then starts or stops the machine. The controller then handles the washing, rinsing, and spinning cycles. And finally, a display shows a completion message after the completion of the selected input. Hardware and the connections. In the simulation, the PIC16F877A microcontroller is connected to four switches for start, select, stop, and door status. The outputs are simulated motor, buzzer, and the LCD screen are connected on a port B. The simulated environment used in Picsimlab, which models the hardware virtually. My internship goals were During this internship, my main goals were to get hands-on experience in embedded systems and apply my theoretical knowledge practically, learn to write modular embedded C code, and to understand how to document and present an embedded system project. Development process and tools. Here we can see my development process include studying requirements, designing a logical flow, writing code using MPLAB X with the XC8 compiler, and the testing everything with Picsimlab. I also practice debugging and documentation as a part of the process. Some challenges I have faced were switch debouncing, managing the timing of simulation watching cycles, handling program flow with multiple user inputs, and coordinating testing and debugging without the access of physical hardware. The outcomes were For me is the key outcomes were that I have completed a working washing machine simulation cycle, improved my knowledge of embedded C, practiced using Picsimlab, strengthened my debugging skills, and gained confidence to work on more industry level embedded projects. My future enhancements plan were this project could be extended to real hardware implementation or enhanced with IoT features such as Wi-Fi control, mobile app integration, or even remote monitoring of the washing programs. In conclusion, this internship strengthened my embedded system fundamentals, improved my programming and simulation skills, built my confidence to handle industry grade projects, and thank you. Let us see the code of this project. Here we can see the code in IDE. This code is written for a washing machine simulation using a PIC microcontroller with a CLCD, digital keyboard, fan, and a buzzer. It covers the program selection, water level selection, and starting and stopping the machine and managing washing cycles. The init The initialization function sets up the CLCD, the keypad and the timer too for timing operations and configure the output ports. And for the fan and the buzzer, the interrupts PEIE and GIE are also enabled to allow peripheral interrupts. In the main function, we can see the program first shows the welcome screen asking the user to press SW5 to power on. After pressing SW5, it calls the power on screen function to show a simulated power on effect. After that, it uses a while loop to continuously monitor key presses and change the operations mode between the program selection, water level selection and stop screens. The program uses a variable called operation mode to keep tracking of which screen to display. There are states like washing, program, display, water, level and stop screen, start program and pause. Depending on the mood, switch statement decides which function to run, for example, washing program display or water level display. Run the program. This function, the washing program display. Let us take washing program display function. This function displays a list of washing programs on the CLCD. It allows scrolling through programs using SW4 and wraps around to the beginning after reaching the end. It marks the currently selected program with an asterisk and it shows two other options below. In water level display, similarly, the water level display allows the user to select water levels from auto to max. It also uses SW4 to navigate and wraps around. Set time for program. This function calculates the total time in minutes and seconds for the given washing program and water level. For example, if we select the heavy program with high water might take longer than the daily program with low water. This function, the door status check function, checks if the door simulated on RBO is open. If it is, it stops the timer and fan, sounds the buzzer and displays a warning. Once the door is closed, it resumes washing automatically. The run program, this is the heart of the simulation. It first shows the selected program and its timing and then starts the timer and the fan. It divides the cycle time into wash, rinse and spin periods. It constantly updates the display with remaining time and shows the active function. If the SW6 is pressed, it pauses the machine. If the door opens, it stops everything and shows a safety warning to close the door before resuming. At the end of the program, it turns off the fan and turns on the buzzer and shows the remove clothes message. The code also uses the TMR2 to handle the timing for the washing machine. The fan simulates the motor running the drum and also uses this code uses a simple finite state machine concept with clear codes modes for user interface, program selection, water level, program execution and complete handling. Let us see how we can see that in Picsimlab. Here we have opened Picsimlab and the board is Genius and the microcontroller is PIC16F877A. We can load the hex. The hex is generated when we run the code in this run the code. Let us turn on the washing machine by selecting key 5. We can see the display that it is showing the status. If we select once, it will changes the available programs. Here we can see that it is changing the available programs. Let us choose daily by long pressing the key. Now it came to water level. Here we can select the water level as required. If same as the previous one, if you select once, click once, it will change to the next level. If we long press the key, it will go to another. Yeah, we by long pressing the key, we can select the auto. Now we can see press switch SW5 to stop, SW6 to stop. Now we can start the machine. We can see the program function was 5 to start 6 to. Let us see how to pause the machine. If we press this, we can pause the machine. You can see the fan has paused and the cooler has gone. Now we can start. It will continue from where it has stopped. Now the function is in wash. The function has changed to rinse and then to spin. And you can see the message after completion. Open the door and remove the clothes. And you can also hear the buzzer sound. Overall, working on this internship project helped me to learn a lot about embedded system and hands-on coding. I am grateful for the chances to apply my skills and building a working simulation and gain confidence to handle similar projects in the future. Also, I would like to thank Emertxe for guiding and supporting me throughout this internship. Thank you for watching my presentation.